All right, so 7 says to find the area of the blue shaded region. So for 7, the red is the information that's given, right? And then it says to find, I want the blue. So if I know 2 things, 1, the arc measurement and the area of that small red one, I would need to know what to find the area of the rest of it. Like, what are you missing? The radius. So if the area of a sector equals the measure of the arc over 360 times pi r squared, and I have the area, it's 27.93, and I have the measure of the arc, then I can work from here. So I could cancel out the zeros just to make my life a little bit easier. But because it's in decimal form, I can multiply both sides by the 36. Or I could have kept 360 and multiplied by 360. Like, it's up to you. So 27.93 times 36 is 1,005.48. And then the 36 is gone, so I have 5 pi r squared. Then I can divide both sides by pi, and then again by 5, or I could divide both sides by 5 pi. If you do that in the calculator, you got to group together that 5 pi. So 1,005.48 divided by, open your parentheses, 5 pi gives me r squared is 64.0, which tells you r is 8. That's the first part though, right? It's not asking for radius, it's asking for the area of the rest of it. So you have 2 choices from here, I would say. Find the area of the whole circle using 8 as its radius, and then subtract the 27.93. So if you did that, it would be pi 8 squared, or 64 pi for the whole thing, minus the area of what they gave you, 27.93. And you get 173.13. Or you could find the area of the shaded region using 360 minus the 50, which would be 310 over 360 times pi 8 squared. And you get the same answer, 310 times pi times 64 divided by 360. Same answer, 173.1. Well, 1.4 on the other one.
Using the formula?
You got to use the formula to get the radius. So you got to work backwards to get the radius, and then you got to use the radius to find the area of the other side.
You just plug in the values?
Yep. Nick?
So for the first one, all you have to do is square 8 and then multiply by
For, if you mean the first method. Yeah, like that gives you your, like 64 pi is your full circle, and then take away the red part. So this is like the 64 pi is 201.06, and then subtract that 27.93. I think that way is a little bit easier, but both work.
Where did we get 201.06?
201, that's 64 pi. So once you find the radius is 8, then the area of the whole circle would be 8 squared times pi, which is that. Mars.
What was the point of that question?
The final answer, 173.13 or 173.14.
Find the area of the whole circle?
No, the area of the shaded region, so the blue.
Oh, that makes sense.
Yeah. If it said
So
full circle, it'd be...
You have to find the area of the whole circle and then subtract 27.9.
Correct. Yep. 6? Yep. Yeah. All right, so again, blue shaded region, right? So this time I would want to do the area of the rectangle and subtract from it half of the area of that circle, right? Because it's half a circle. So the rectangle is 6 times 4, or 24. And then the area of that circle, this whole segment would be 4, which means the radius is 2. So the area of that circle would be 2 squared times pi, or 4 pi. But there's only half the circle there. So half of 4 pi would be 2 pi. And then 24 minus 2 pi, 17.716, or 17.72. Other questions from the first page? Page 2, now we're on areas of polygons. So this was again like the ones without SOHCAHTOA would be the hexagons and the equilateral triangles. And someone just asked me a good question, like couldn't you do the area of something like an equilateral triangle using SOHCAHTOA? The answer is yes. The problem is if that answer, which I'm pretty sure it is your exact answer, you have to use it using the 30, 60, 90 triangles. You can check it the other way, but you're going to have to use your special triangles on those. And then the area of the rhombus is on this too. We're good on those? Yes. Okay, how about 11.4 and 11.5? Now we're into the cross sections, which were 18, 19, 20, and the faces, edges.
The number of 18.
Yep.
Say rectangle.
Yep. Wait, 18 for the cross section part, yes. But then it said count, so make sure you also know how to do that. You're gonna get like one question where you have to identify a cross section and one question where you're gonna have to count.
Count what?
The faces, vertices, and edges.
That's a question?
That is a question.
Someone gets that question wrong.
Same for the cross section. Should be super easy, right? Yeah.
Wait, so that cross section is a
At
rectangle
least
and not a
getting
rhombus?
10%.
That is a rectangle. You mean 19
Yeah,
would be a square?
Pyramid.
yeah.
Well, the cross section's just a square. And obviously it's not gonna be purple because it's a black and white test, so don't rely on that purple.
So wait, why would it not be a rhombus?
It's shaded. I'm sorry?
Why is it not a rhombus? Oh, because the bottom is a square and
Correct. I mean, technically it is a rhombus, but it's more specifically a square.
I'm just asking questions.
He's just breathing heavy. I don't think he's annoyed.
Um,
All right, questions on the volumes at the bottom. Volume or cylinder or prism. Mariana. 23. Okay, so this is a prism. Volume is base area times height.
Rectangle prism.
Say it again. Pentagonal.
Pentagonal.
Close enough. Okay. All right, so the base is a pentagon, right? Actually, this is a really bad example, though, because you won't have to use SOHCAHTOA. So if that base was a hexagon or a triangle or a square or a rectangle, then I'd worry about it.
Pentagonal prism.
All right, questions on 11.6. Now we're dealing with pyramids, and then you had your composite and you had your similar. Yeah, 11. All right, so the composite solid this time is made up of half a cylinder and a cube on the bottom. The volume of the cube would be 5 times 5 times 5, or 5 cubed, which is 125. That's the bottom. And then the top is half a cylinder. So volume of the cylinder would be what? What's the formula for volume of a cylinder? Good, pi r squared h, right? And then it's going to be multiplied by a half or divided by 2. So the r, if this whole side is 5, the radius is 2.5. So pi 2.5 squared times the height, which is 5. And then pi 6.25 times 5. Did it say it around? It didn't. Did it right? Yeah. Okay. So I'm going to multiply that all out. And the volume of that cylinder is 98.2. Easy killer. Don't flip over. But it's only half of it, so divide that by 2. Can you help him out, please? Be a good human being. And then add those two together.
Impossible challenge.
And it just rounded it to the nearest whole number, but that's what it would have been. All right, this bottom is what?
It's just a pi factor.
The bottom is a rectangular prism, right? 5 times 11 times 6.
It's a trick question.
It is not a trick question. So the bottom is 330. The top is half a cylinder again. So if all the way across is 5, halfway across would be the radius of 2.5. And then the cylinder would be, what's the formula for a cylinder? Pi 2.5 squared times the height, which is 11. 2.5 squared times 11 times pi is 215.98. Add that to the 330, and that's where the answer comes from.
Can you make the picture bigger of it?
I don't think, I mean, I'd have to crop it. It doesn't really get bigger. Yeah. Yes, divide the cylinder by 2. Thank you. This divided by 2. 215
I was about to say, because like 200 and 300, but they
plus 330. And that's, yeah, 438. What's the formula for arc length? Measure the arc over 360 times the circumference, or in this case, goes through the radius, 2 pi r. So that's 1/3 times 12, 4 pi.